Today we're talking about no XML, how to get rid of it in your spring projects. My name is Matt Raible. I'm a hick from the sticks. I grew up in the backwoods of Montana without electricity or running water. I did have to walk 2 miles to the bus stop every day, and it was uphill both ways. I love VW buses, particularly that yellow one. I bought it the same month that Spring 1.0 came out. And I like vans too, but I never expected to. This blue one's ours as well. And boy, that's one of the ugliest cars on the planet. But somehow I find it beautiful now. I never thought I would. So I'd like to learn a little bit more about you. How long have you been programming in Java? Anyone more than 20 years? Came out in 95. Did you start programming that next year? We got one. Anyone 15 years? 10 years? Last 5. Anyone started in the last year? We got one guy? Cool. Welcome. Who read Rod Johnson's first book? J2E, Design and Development. I got like 5 or 6. Pretty revolutionary, right? That's where Spring came from. Did anyone ever use struts? Okay, keep your hand up if you used struts too and you migrated. No one migrated. It didn't really work. Okay, so we got like 30 people that use struts 1 and probably 20 that use struts 2. Anyone use the CG security? Okay, about 5. And does anyone have their most memorable development nightmare that they'd like to share? If I was in a foreign country over in Europe, I know not to ask this question because you have to basically wait like 2 or 3 minutes before anyone responds in the audience. But we're in the US, and people are friendly, so anyone? No? So this talk is about no XML. I've come to the realization over the last 15 years that most of the XML I was writing to configure things in my applications, I'd never change. Right? I would configure it to use this way with Spring. I'd configure my web XML this way. And part of the reason for doing that was so you'd have dynamic configuration or the ability for you to change things without recompiling the code. But I really found I never really did it. And so what was the point of XML? It's just, it's easier if it's Java because then if you change something, it still works. With XML, a lot of times it was runtime. So I actually created this talk a week ago today. The conference is coming up. I got a week before I got to speak in front of y'all. And I was sitting there going, how am I going to come up with a good talk about how to eliminate XML? It was a Thursday night, and I had a camping trip planned with my family that weekend. So this is last weekend. We're going up to this place called State Bridge on the Colorado River doing some rafting. And I'm also working on this book, this JHipster book. So I was thinking to myself, I told InfoQ, who I'm writing it for, that I'd have the final chapter done by the time I came to this conference. And I had to write this presentation, and basically I'm thinking, how am I going to pull this off, right? It's 9 o'clock on a Thursday night. So I said to myself out loud, parallelize. And I said, I don't even know if this is a word. So dwell on that for a while I get some new batteries. Thank you. So I did Google it, and it is a word, and it means kind of what you think it means, that you try to do 2 things at once. It's often used in computing. So I said, how am I going to do this? I'll do them both. I'll write the presentation and talk a bit about JHipster and the end of the book and what I'm going to write there, and then I'll write it and I'll write the presentation at the same time. And so I did. I cracked open a beer shortly after that because this is a blog post I wrote in 2006, tips for happiness and productivity at work. And you'll notice that number 3 is work on open source late at night with a beer on your desk. So wisdom from 10 years ago. Or maybe it was, regardless, I said it out loud, struck me as the right thing to do, and I was, happy to take one of my own tips. Some other ones that aren't on there that I think are good are avoid meetings at all cost. That's a good tip to be happy at work. And work on something you're passionate about. So I had this JHipster book that I'm writing for InfoQ. I've written about 100 pages. I got the sample app done and everything like that. I just need to close it out with the final chapter, which is about API building blocks, Spring Boot, and a lot of things that JHipster uses. So I'm going to combine the two in this presentation. And so I got to thinking, Java is really good at building APIs. And it really stinks on the desktop, right? It's kind of failed there for the most part. Would you agree? Raise hands if it's failed on the desktop. OK, good. We got about 20% of the room. I expected more hands. Because does it really? Because we got this thing that's pretty awesome. It's written in Java. And if you asked kids that are my son's age, which is 11, they might think that this is the best thing that's ever happened to the desktop with Minecraft. And so Java really hasn't failed too badly on the desktop. Interestingly enough, if you look at the top of that Minecraft launcher, it says you should download, you have an old version of Java, please consider using the new launcher, which doesn't require Java. It will make your game faster. So I was like, really? Microsoft, you bought Minecraft, and you rewrote it in the first year so it doesn't use Java anymore? I mean, come on, this was their biggest, success story. So I went and read the release notes, and it says the primary and newsworthy change in the launcher is that now it downloads a standalone version of Java that is independent of the general location installation of Java on the host machine. So that's pretty cool. They basically did what Spring Boot did and said, we're going to embed your application server inside the game, and now you don't have to worry about downloading Java. We'll just embed it. So it seems to be a trend in most people that are using Java. So Minecraft is not sexy, right? It doesn't inspire oohs and ahs like the first iPhone did from adults. However, it does capture the attention of our youth. And it captures it more than the iPhone did. I mean, if I let my son play all day, he would. And he would, come to me at like 5 o'clock and be like, hey, Dad, I haven't eaten. What's for dinner? And be like, well, that's your responsibility. Like, find the food. So APIs on the JVM have been great. And this is a quote from Jay's governor of Redmonk. Only a couple years ago, when web companies grow up, they turn into Java shops. Not so much Java shops per se, but more JVM shops. So this is from Jax London, October 2013. He says basically LinkedIn, Google, Twitter, Yahoo, and Facebook, among a host of other web powerhouses, have all turned to Java in recent years to power them into maturity. Here's an interesting quote from him as well. Looking to the future, Governor said that web frameworks are the best way to understand language adoption. After all, Ruby was just a curio until Rails came along, and Django and Node have led adoption to their respective languages. Despite a ton of options, Java still has yet to develop a leading framework. And Governor reckoned that to see explosive growth again, it will need one. So that's 2 years ago. I think there's a lot of good things going on in Java land. We have big data, and this is what a lot of companies are turning to for their JVM usage. With Hadoop and Storm, primarily written in Clojure. We have Kafka, which is written in Scala. Cassandra is Java, and Apache Giraffe is Java. So they're choosing this sort of tooling based on this affinity with Hadoop, sharing Java libraries. And Hadoop is a Java language phenomenon rather than a simple JVM phenomenon. And of course, Spring XD makes it easier to use Hadoop, if any of you are using that. And then we have Groovy and Grails. Really have done a good job in making web application development easy. And we have Scala and Play, the reactive style web applications. And we have Spring Boot. And announced this week, we have Ratpack, which is a reactive way of building on top of Spring Boot and making your applications scale faster and not do blocking I/O. So Spring Boot wasn't the first. There was Dropwizard before it. It kind of took that model of building something and packaging everything with a Jetty embedded container and making a microservice framework. There's also Jersey or Apache CXF, REST-easy, and Vert.x. Those are all ways of building APIs with Java. And you know what Dropwizard did right and what Spring Boot did right? Logos. If you're going to have a good web framework, you need a good logo. That was always a frustrating thing when I was comparing web frameworks, is having all these web frameworks with no logos. GWT was one of the first ones with a good logo. So good job on the Gwt guys. So Spring 1.0, looking back, came out in March 2004. And it had dependency injection, it had AOP, it had Spring MVC, it had generic DAOs. I don't recall those so much. They didn't have an implementation like Spring Data does, but in the release notes it says they have that. In 2.0, they came out with the big thing, which was extensible XML configuration, portlet MVC, so I don't know how far that went, and message-driven POJOs, which people used a lot. And then in 2.5, November 2007, it took them a few years to get there. That's when they came out with the annotation-driven dependency injection and auto-detecting application components in the class path, auto-configuring them as Spring-managed objects, officially supporting WebSphere, 2007, good work there, and packaging of Spring Framework jars as OSGI-compliant bundles. I don't know if people use those, I did not, but they were there. And then Spring 3.0 comes out with Spring Expression Language, REST support, MVC improvements. That was a pretty big release, model validation, and some core features of the JavaConfig project were added to Spring at this point. And this was basically a way of not using XML in your projects and starting to use more Java. So I have this quote from Wikipedia. If you go to Wikipedia and look up the Spring framework, Spring has also been criticized for what some developers perceive as an over-reliance on XML. Creating an application using Spring requires one to spend a great deal of time writing or debugging XML files instead of actual Java code, leading many developers to feel like they are programming in XML rather than an actual programming language. However, since version 3.0, developers have been able to specify all or part of an application context through annotations. Spring Boot makes heavy use of this to minimize the amount of configuration that must be written. So no one's went and corrected that. It's interesting because it's kind of old, it seems like, right? Wikipedia, though. And so we've often been criticized as Spring developers for using too much XML. We're going to figure out how to get rid of that. Spring Boot has been with us only for a couple years, but it's like a breath of fresh air for the Spring community because it shows us how powerful annotations can be, or rather just Spring without XML. Now, a lot of people seem to agree with this. It's got 2,800 stars on GitHub. It's got even more forks, and I think forks is a bigger representation of good things for a project than stars because it means that people can understand it and they can improve it and they're forking it and contributing back. So Spring Initializer at start.spring.io is pretty awesome. Has anyone used it? Great projects? A few people? So you'll notice if you go in there on the UI section, they don't have a whole lot. They have Timeleaf and they have Vaadin. Those are like the way of creating, good UIs with Spring Boot. So it's pretty easy. You can do it with curl. You can, do it in the browser. So if you like that, you're going to love JHipster because JHipster is basically Spring Boot on steroids. It gives you a modern web application with Angular, Spring Boot on the back end, allows you a bunch of choices to actually configure your application, allows you different authentication mechanisms if you want. You can use OAuth, you can use HTTP session. It basically, with vanilla Spring Boot, it's like if someone comes to your house every Friday and cleans for you. You're like, this is pretty sweet. I'm glad that this person came, cleaned my house. It's nice to hang out in tonight. JHipster is like if someone comes over, takes you out to a dive bar, you have a good time on Thursday, and then they drive you home, and then Friday they show up, make you coffee, make you breakfast, send you on your way to work, and then make you a cocktail before you get home at night. It's that much better than the vanilla Spring Boot. Maybe that's a bit extreme. But it's a lot better than J2E that Rod Johnson originally wrote about. That was like the college roommate that never cleaned up at all. So with Spring Boot, you can create standalone Spring applications. You can embed Jetty, Tomcat, or Undertow. Has opinionated starter palms. For the most part, when I first started using it, it's just a set of dependencies that you put in your Gradle file, you put in your POM file, and then it simplifies. Instead of putting 20 things in it, you put 1 or 2 in, configures all that for you. Supports, promotes using Gradle, and I'm sure you've heard a lot about it at this conference. Luckily, I'm not going to talk about cloud today, so you have that going for you. It automatically configures Spring, production-ready features, metrics, health checks, no code generation, no requirement for XML, and even Gradle 3 is based on it. No requirement for XML, pretty handy. So what does JHipster do? It's got these backends. It's got this Spring Boot, Spring Security, Angular JS, Bootstrap, Bower metrics. It's got all that as part of it. You can use 7 or 8 for Java. You can use Maven or Gradle. You can use different types of databases, SQL or NoSQL, Hcast or Hazelcast or Grunt or Gulp. Uses Yeoman to actually build everything. So if you've used Node or you've used Angular, you might have used Yeoman to generate projects. So it's sort of like Spring Roo or my project that I started a while back, AppFuse, in that it kicks out a bunch of pre-generated code and you have something to work with. Has anyone not heard of BrowserSync? First of all, how many people do browser-based development? So they're writing code and seeing it in a browser every day. Okay, so 10 of you. Of those 10, has anyone not heard of BrowserSync? Raise your hand if you haven't heard of it. Okay, I'll play the video then. So there's a video I got embedded in here. I think they told me not to do this, but I'm doing it anyway. See if I can get it to play. Well, we can just go to the website here. You don't see anything over there, I know. So we'll drag this over. Play it. See if you can hear it. Looks like it's failing. So, failed demo. Try it if we see everything. I mean, if it's going to be my first failure, I'm happy that someone else.
BrowserSync will automatically reload all browsers whenever your files change. So for example, if we had a class here and hit save, all browsers are reloaded. This works for CSS too. In this example, we are compiling Sass into CSS, and then BrowserSync picks up that changed CSS file and injects it into browsers. We also synchronize scroll position as well as clicks and form inputs. We have a user interface that allows you to toggle sync options on or off, as well as track history and push URLs to devices. And we also offer remote debugging using the popular Winery project, as well as some simpler CSS helpers and a latency throttler, so that you can test your website on a slower connection. BrowserSync is a free project, it's open source, it's installed on the command line via npm.
So it's pretty sweet. If you're doing web development, you never have to refresh your browser again. You just configure it, starts up, and on my project, we're using Google App Engine on the back end. It's Python, it's out there running. I develop an Angular client, and I talk to it, and the workflow is awesome because you just make change, go back to your browser, and you see it. If you have 2 screens, you don't even have to switch between contexts. So pretty awesome tool there. So we've got some parallelizing to do, right? We're back to that. Spring Boot helps eliminate XML. JHipster makes Spring Boot even better. Combine their model for eliminating XML and building awesome APIs on the JVM. So I thought to myself, okay, I need to figure out what I originally wanted to do. I'll get to in a minute. But I want to take a look back. Remember all the XML. Remember struts.config.xml? I went back and looked at AppFuse way back in 2004 when Spring came out, and I had this other project called Struts Resume, and I tried to build them, right? Because what I found was struts config was generated from xdoclet. So I was never writing that file, I was generating it. I was using Ant. So I went and tried to build that this morning, and it didn't work because J2EE home wasn't found. And so I had it configured to look for files in my local directory. That struts config file was 599 lines. So a lot of XML there. The build.xml that I used to build that struts config file was 1,533 lines. So you think Maven or Gradle is bad. Remember Ant. So much so that there's a tool from SourceForge called Clock. It counts your lines of code. It has its own category for Ant. when I ran it on the AppFuse build, it was like you have this number of XML and you have actually 1,550 lines of ant. Right? It doesn't even call it XML. So like I said, I tried to build it this morning. Didn't work. And I wasn't about to go and try to find a J2E SDK from 1.4 to make it work. And then I said, well, okay, well, let's look at my Spring file, looking back still. And application context, looks like that was partially generated as well, or XML entities, right? So we were programming in XML. We weren't writing Java code as much. And then we have one of the worst offenders of XML in Spring projects, a CG security. And if you look at this one, this is an article from 2007, a CG security in 1 hour. What happened to 10 minutes? Why does it take a whole hour? And the reason was because they had files like this, right, where you had to specify all your filters, and Spring likes to give long names to all their filters, so it was kind of tedious to look at. 213 lines of code in the CG XML file that I had in this particular project. So here's where it gets interesting. I was originally planning on getting up here and generating a Spring MVC application with AppFuse 3.5, which we put out in February, and eliminating its XML. Actually, I was planning on getting XML all throughout AppFuse and then releasing it before the conference, but there was a lot of camping and rafting and driving Volkswagens this summer, so I never got around to it. Or I didn't make the time, more like. So I was going to generate a Spring MVC app and call it no XML. And with AppFuse, this is what it would look like. You basically do archetype generate, and then you create an archetype. So let's see what that looks like. Copy this. And then I have to mirror the thing so you know what I'm talking about. All right, so you can see everything over there. So if we run that command, first of all, let's make sure there's no project there. So it worked. We got no XML. We got this project here, and we can run command on it. See what that looks like. I'm going to try to make this font smaller. Hopefully you can still read it. Can everyone still read that okay? Yeah? So you can see here, this is a base AppFuse project. It's got Java, 2,300 lines of code. It's got XML. 1992, year I graduated high school. It's pretty cool. Nice coincidence there. So then if I make sure that everything works, I'll go ahead and MVN install it. Just basically creates a database, runs a whole bunch of tests against it. I kind of think of it as a typical Spring MVC legacy app nowadays. We've done a lot to make it more modern, but we haven't really stripped out a lot of the XML. So this is what I wanted to show you, right, is how to take this and strip out the XML. So it actually builds a war, and then it fires up Tomcat, and then it runs integration tests using GNU web test, which is kind of outdated too. A lot of people use either Spring MVC test or they use Selenium with HTML unit if they want to do it headless. And so there we are, 29 seconds. It built the project, installed it, ran all the tests. And if we run clock again, wow. So we got more XML just by building it. Right, it went from 1992 to 2394. Trivia. Does anyone know why? Oh, right, moved to the top, 2717. Does anyone know where it comes from? It's from Maven, but where? It's not from the dependencies, it's from the good old Target Surefire reports, right, from XML reports. So if we, rm-r, target, go back, we're back to 1992. So, just to be aware that if you're running clock on a existing built project, you might get more XML than you actually have in there. So because I'm going to post this presentation online, and it's nice to have slides to show what I did in the demo, here's a quick start guide that you can copy that command from on appfuse.org. Here's what it looks like when you run that command. Generates everything. It doesn't take too long to do it. And when you run clock, you get 1992 on XML. So AppFuse has a number of features. We can look at a demo here. So if you go to demo.appfuse.org, we could look at the Spring MVC and Hibernate one. You log in as admin. Then you can edit your profile. You can, as an administrator, look at your users. You can update it. You can also go and, upload a file. So not a whole lot of features, but basically a starter and, has a bunch of testing and stuff like that built in. So it's got authentication, it's got user management, it's got Bootstrap and jQuery integrated, REST API with CXF, Hibernate and JPA support, and CRUD generation. So it'll generate, your UI and all their entities and managers and things like that for you. It's also got internationalization. So I said, well, compare that to the poster child for no XML, and you have a default JHipster application. And it's got authentication and security. It's got Spring Boot metrics. So Spring Boot has all these metrics when you add actuator to your class path, and then what JHipster does is it shows you what those look like. It's got Bootstrap and AngularJS integrated, REST API with Spring MVC, JPA support and NoSQL, and CRUD generation. So a lot of similar features. It's pretty hip, right? AppFuse is not. AppFuse is old. It's got a lot of XML in there. So just to show you, some of what JHipster looks like, because I think those are some, cool dashboards. I wrote 2 apps for the book. One is jhipsterbook.com. It's basically a blogging app. We could log in there, but the other one I like is 21points.com. This is a new one I wrote as part of the sample app in the book. This is why we want server-side generated JavaScript, is because the front page shouldn't take this long to load. All right, so if we just log in here, you can see it's got entities here, it's got account, and since I'm not an administrator, I got to log in as administrator to show off the dashboard stuff. So under here, it's got metrics where you can see how much memory you're using. This is all running on Heroku. How many HTTP requests are going. So Spring Boot provides all this information. They just put a UI on it. You can see if your database is running, if your mail server is running, if you're OK on disk space. The configuration for your application shows you all that configuration. Even goes into auditing, so you can see who logged in when, and it has all that in a nice UI. You can also adjust your logging. So if you wanted to turn it up and change it from info logging to debug logging, then you can do it on this table. It just doesn't work very well on a small screen here. And then it's got Swagger as well. So it's got all those things built in. Pretty cool that way. So we kind of want to make AppFuse more like JHipster and make it a bit more hip. So we already went through all those. So the final chapter of the JHipster book, this is what it looks like. Spring Boot, Maven, Gradle, IDE, support, security, JPA versus Mongo versus Cassandra, Liquid-based, Elasticsearch, Spring WebSockets. I was like, how do I relate all this to no XML? I can see it with Spring Boot, right? No XML there, so that's a good way to do it. Maven versus Gradle. Don't use Maven, you can use Gradle and you get rid of XML. So things are starting to come together. So let's compare the two. Let's compare what AppFuse does and what JHipster does. Both use Spring Security. AppFuse uses Spring Security 3.2.5. JHipster is 4.0.1. We have Remember Me. We have HTTP session authentication. We have ZAP tested. Z attack proxy is something from OWASP that you can use to basically pen test your own application. And then JHipster has improved Remember Me. They've done a little better than the default for Spring Security. They have cookie theft protection. They have CSRF protection, authentication, HTTP session based. You can do token-based, you can do OAuth too. With JPA, they're both included in both. How much XML? Well, with AppFuse, there's like one file, so not a whole lot. It's got a generic DAO architecture. It's got that persistence.xml. They're both based on Hibernate. JHipster uses Spring Data, gets rid of some of that XML, gets rid of that persistence.xml, and it's got repositories. So you can easily, using Spring Data repositories, create dynamic finders just in an interface. It generates those for you. It's a nice way to query your database. Schema generation, both of them generate databases and both of them populate databases. Hibernate 4, DB unit for AppFuse, Liquidbase, and CSV for JHipster. Liquidbase uses XML. Those bastards. So, that's the majority of the XML files in JHipster. You can actually use something else. You can use YAML or JSON if you want. Search, we use Hibernate Search and AppFuse. They use Elasticsearch. With Hibernate Search, just some annotations. With Elasticsearch, one annotation instead of multiple. WebSockets, AppFuse is not hip, no WebSockets. With Spring WebSockets in JHipster, they use Stomp and Boot for the JavaScript side. And then on the Spring side, with Spring Boot, it's pretty easy. Just extend abstract WebSocket message broker configurer. Again, they like long class names. And then enable WebSocket message broker is the annotation you'll use to set those up. So what about code? Let's look at a JHipster app, right? We generated the Java one, or the AppFuse one. Now we'll generate the JHipster one. So we'll remove this one. Oh, no, we'll keep that one. Can't see, sorry. Back to mirroring, thank you. So we're going to go ahead and make a new directory. This is the first thing I mess up with JHipster. We do no XML JHipster. And then you just do yo JHipster. Yo is a Yaml command. So it says, what is the base name of your application? I'm just going to accept the defaults. Default package manager, AS Java 8. I'll do HTTP session. I'll do SQL database. MySQL for my regular database. For my development one, H2. Use EHCache. No Elasticsearch. No Hazelcast. No WebSockets. Go ahead with Maven. Grunt. No SAS. And yes for I18N. So this is far from speedy, you'll notice, as we sit here and wait. So who thinks Maven downloads the internet? Right, that's been the big talk, like Maven stinks, it downloads the internet. And then you try Gradle and you're like, it does the same thing. And then you try one of these new tools, NPM, even worse. It downloads the internet and their friends. So when I last timed this, it's about 2 minutes here just to get everything down. Now you see it's doing some post-install stuff, so it's downloaded everything. Creating those files is easy, right? It's downloading the dependencies that is the hard part. And everyone has the problems that we've had with Maven and Gradle and dependencies and transitive dependencies. JavaScript has the same problems. So it's interesting to see those come back, right, as you migrate to new frameworks. So it's going through, it's building those. And then once it's done, we're going to run clock on this and see what that looks like, right? We're trying to get this ideal application that doesn't have any XML in it. We want to do some comparisons. We have until 2:15, right? Seems like I'm got some filler here, doesn't it? Good stuff is coming. Yeah, because basically once JHipster installs the app, it's yours. It's just like AppFuse. There's no tie back to it. You can upgrade it, and it will like overwrite files, but basically you should take it, call it yours, upgrade your dependencies your own way, and do it that way. And if there's a new release that comes out, you can always generate the same app and like diff them, right, and compare them, but you can certainly do whatever you want. So this is done. That took 2 minutes, 13 seconds just to generate it. So AppFuse wins there. It's like a second. But if we go, okay, clock. Whoa. So it sounded good, right? It's supposed to be the poster child for no XML. We're up to 38, 9, 4,000 files. So this is one thing that Node does differently. It installs everything in your project versus Maven installs it in your local repository, right? So it's kind of separate outside of your project. Last time I ran this, it didn't take nearly this long. So we'll come back to that. So here's just the quick start guide. And because I had everything set up, I didn't actually have to go and do a lot of these steps. They want you to install Java, Maven, Git, Node, Yeoman, Bower, Grunt, and then JHipster. So the getting started, the installing the software to create an app is quite a bit more. This is what it looks like. Those are the choices I made. You can see here when I did it at home, it took me almost 3 minutes. And when I ran it, it had basically 4,000 lines of Java and only 271 lines of JavaScript. So that's pretty good. Let's go back and look at this one, see if it's done. Nope. Still cranking away. So that screenshot that I showed you is from after I deleted the node modules in the Bower components directories, because those are where it's counting all the code at. So if we delete those and look at them, the lines of code difference, JHipster has 4,000 Java, AppFuse is 2394. They have similar features. JHipster's got a few more. We have a lot less JavaScript, 76 lines of JavaScript. They have 861. And XML, we have the 1992. They have 271. So that's pretty good. So let's look at how we eliminate this XML. In AppFuse, we have all these XML files. There's 26 of them. And basically, they map to application resources, maps to build, or actually pom.xml is a build file. Right? Application resources is like the configuration for the database. We have default data, which is for DB unit. We have cache. We have Hibernate. We have log4j. We have persistence.xml for JPA. We have a bunch of Spring files. We have some site mesh files. We have some validation files, some web.xml, wro.xml, and site.xml. So a lot of stuff in there. This is basically all the things that it maps to. So how do we get rid of these? Basically, with Maven, you can convert it to Gradle or Polyglot for Maven. And this is basically a tool for Maven that allows you to write your POM files in a different syntax. You can use Groovy, you can use Atom, you can use anything that like YAML, but Gradle works as well. Spring XML will use the JavaConfig. DB unit, they have a dataset builder, so you can actually write your loading of data with Java code if you want. With cache, there's an enable caching annotation, and you can configure it in Java. And then Hibernate has Spring data. Log4j 2 has a proprietary API that you can use, but it might go away in the next release. So it actually specifies that in their notes. And if you look at these slides after this presentation, everything with a line under it is a link to how to do it for that particular framework. With validation, you can use JSR 303, so you put annotations on your objects. The real problem that I have with that versus the way we used to do it with other frameworks is there isn't really good support for client-side validation. Yes?
Like we're starting to trade XML hell for annotation hell.
Right. Are we trading XML hell for annotation hell? Absolutely. That's why Spring keeps taking their 5 annotations and making it into 1. You'll see that with Spring Boot a lot. If you look at stuff from a year ago, they're like, well, you need 5 annotations. Oh, wait, we made a new one, and now there's only 1. So you are right. But the ability to use your IDE to navigate things is a little easier once it is in Java. With web.xml, you can eliminate that with Web Application Initializer as part of Spring. And then there's Maven site is that site.xml that you generate, your site that no one ever looks at. And what has happened now is everyone just does a README, right? And it's much easier to maintain. You don't really worry about these reports so much. Maybe use Sonar to generate reports about your application. So we're 45 minutes in, and I'm sitting there, and it's last Sunday night, right? And I just got back from the camp trip, and it's Sunday night football. I like football, so I was watching football, and I was procrastinating. So I was like, I'm just gonna go to bed. I'll do it tomorrow. So Monday comes around, and I leave to come to this conference yesterday. And Tuesday night, I had tickets to Ben Harper at Red Rocks, so I wasn't going to skip that. So I was like, Monday night, got to make something happen. And what I decided was I had about 45 minutes worth of content, and that it'd be awkward if the talk was over right now and I just told you how to do it instead of showing you how to do it. So I decided that I had to show you how to do it, and that I should take AppFuse and rip out the XML and replace it with Java and make it all work. So I decided that about midnight on Monday night. And the good news is by 3:45 a.m., I had it all working. I even converted it to Spring Boot. So I'm going to show you how I did that with a live demo. So I've already actually put the project out there on GitHub. If you go to my GitHub repo at Raible, appfuse-noxml, you can see the commit logs. You'll probably see the times as well, and some of my mess ups, right, from working early in the morning, and how I made this happen. So it'll probably take me a little bit to get set up here, but we're going to open that project that we created in the noxml directory. I know you can't see it, but I'll mirror it here. And I'm going to see if I can make it a little better because it's not quite wide enough. But then you can't see it. Oh, there we go. So we'll try a couple coding things, and then you guys in the back let me know if you can't see it, because it is smaller than the 800 by 600, but obviously it makes it a bit easier for me. So I can make the fonts bigger there, so you can kind of see the code there. So this is pom.xml, and what you have to do by a default application, AppFuse application, to make it into a JPA application is simply change DAO framework from Hibernate to JPA, and then there's this Hibernate config that you can delete once you've done that. And then what I recommend people do is basically run full source, which grabs all the code instead of using AppFuse's jars. It grabs the code and pulls them down. So that's just a command, AppFuse full source. And it basically pulls it from the Git repository, brings it into your own project. And so the first thing I'm going to want to do is we have this application context resources. You can see here it configures properties, and it configures the data source for Spring. So I'm going to create a new directory, new package. We'll call it config. This is where we'll put our Java configuration. Our first class will be resources config, right? We want to actually configure that same thing with here. So we do configuration annotation there. We enable auto import on those. And if we look back at our XML file, first thing is this properties configure. So how do you configure that in Spring? Well, these are all just Java classes, and all these properties are just methods. So if there was a way that you could write a translator from XML to Java, it wouldn't be too hard. So I started by just taking these and writing them in their Java equivalent. And the first one is that property placeholder configure. So you can see here, it creates a new property placeholder configure. And then it sets those ignore unresolvable placeholders, which is back here, right there, to true. And then it sets up the different locations. So that's pretty straightforward. And we'll add a bean annotation on it, so other beans can access it. And then the next thing is the data source. Right, that's how that's configured. And you'll notice over here, I actually have placeholders, right? Even though it's resolving them, that's a nice IntelliJ feature. Those are actually placeholders that reads, from a properties file. And in the old way in AppFuse, what we do is we actually have those properties in the Maven file. We have placeholders in the properties file, and then we process everything and make it cumbersome for everyone to get those into an output directory. So with Spring MVC or with Spring config, these are all variables here, and then you can basically, not that one. You configure it with a value annotation, and for some reason the live templates doesn't like putting equal signs there. So this is how with JavaConfig you basically get that same behavior with a value annotation where you grab it from that same properties file. So here's our resources config. We can actually delete that file now. I'll just leave it there for reference though. And then we have to configure our data source. So this is our DAO directory, right? We have a persistence exception translator post-processor. We have an energy manager factory, persistence unit manager. We have another post-processor and a transaction manager, and then we scan it all. So we'll call it JPA config. We'll go ahead and make that a configuration class as well. And then we're going to want to mimic that component scanning. So we'll grab that same value. We'll go component scan. Put that in there. And then we have that persistent unit. And there's a data source, so we have to auto wire that. Now we configured in the other one. Okay, so that's what that looks like, similar to the XML file. Then we have a entity manager. Again, the placeholders and our energy manager factory configures, hibernate, sets the diet like dynamically, hard codes everything else, uses the Hcache. And then we have the transaction manager, right? And that just creates a transaction manager, sets energy manager factory, does basically resolves, this bean from this one up here, and you'll see all we have to do is put the auto wired on there, and then it grabs any other bean in the project. Now you could also take this and actually, just do energy you could call this method. That's another way of doing it, right? But because there's more dependencies on this one, it's just easier to, reference it with auto wired. So we should be able to run the test now, right? If we change our test to use this. So we have base DAO test case is the main parent class for AppFuse, and let's just go ahead and we'll find a test in here. Maybe the user DAO test, we'll try running that. Let's make sure that works before we refactor anything to use something new. Okay, so all the tests pass there. So we have all these XML files. How do we get rid of those? Well, you change it from location to classes. And then if you want to do multiple, you do resource config. And JPA config. And then let's try to run it again. Okay, so this time we got no suitable driver. It's kind of tough to see that. Connect class URL. So I think this is because the name changed. So this is what I did. The reason I went and created this project right on GitHub, so in times like this I could go look at it. So it's not that, it's AppFuse, no XML. We have all these commits. Let's bring XML to JavaConfig. So we've got the configuration, the component scan, all that looks right. I do have name. right here. Yeah, and I have that on the other one. Right there, see? Then configuration resources, there it is. And I wanted to get bit on this. I did not put that in there because this is something that when you do this, you're like, why is that happening? What happens is those properties aren't getting injected into those because if you have any lifecycle beans in Spring, you have to make them static. And so if you add the static modifier to the property placeholder configure, then it'll work. So I sort of wanted us to have that experience together so we'd remember we need that. Entity not found exception, I'll take that. That's better than, something's not configured right. So it says ID 3 not found. Chances are this is just because I'm, not loading up DB unit. So we'll go ahead and do mvn test d user DAO. Oh, we got to do the full name. I used to like that about Ant, that you just had to do part of the name. So those aren't working. Entity not found, and an expected object retrieval failure exception. So this is another part that I wanted to fail on, because what I've done is in those XML files, I configured these persistent exception translation post-processor, right? And I don't have this in JavaConfig. So in here, I can go ahead and add it. It doesn't have to be static, but it's just a bean that gets picked up, basically. So you have to add that in there if you want your exceptions to stay the same. So a lot of the stuff in the XML files, sometimes it gets picked up. Sometimes it doesn't. So that's why you have the before test and then the after test. So now that's actually running. And now we can migrate our service XML file. So this one has a bunch of AOP stuff. It has transaction advice and mail engine, velocity engine, and some password encoding stuff. So we'll go ahead and create a new service config. So this one has enabled transaction management, just some handy, basically annotations that Spring provides to simplify. Instead of having annotation hell, you get like a couple of them instead of a bunch of them. And so this again uses those placeholders, uses a value annotation to get them from that file. And these all look similar to the XML file, so it's just, the password encoders, some of them are named because we expect certain names in other parts of the application. So then, if you look back at the service config, one of the things in here is this AOP bit that says, hey, on user transaction manager, I have this advice that I want to roll back for a user exists exception on the save method. So with annotations, you can do that same thing by going to the save method and adding transaction O, and then roll back on user exists exception. So that's how you get that same behavior. And then to get aspects, we have this user exists exception. Or not that. We have that aspect. What's that called? User security advice. And we can add a aspect to that. So basically it takes care of all that XML we had. We have a lot less code now, and it's easier to maintain because it's in Java. It's not in XML. So our base manager test case, we can now migrate that one. So instead of using all of this, well, let's go ahead and run it first, or we'll pick a test in here to run under our managers or our services. We'll go ahead with that same user manager test. It doesn't like something, failed to load. I don't think I changed the file. Oh, I did, look, I put a D up there. So that passes, and then we can, basically modify this one to use classes as well. The resources, config, JPA config, and service config. Then we run it again. And this has something about transactions. And it's funny, at 1 in the morning, and you can't get stuff to work, you know what you do? You go, I know how to fix that test. So if you look at the source code on GitHub, it actually has something like that in there. So I did figure out how to get that one to work. But I think it's something to do with transactions and I'm not supported or whatever. So if you want to help me, feel free. So now what I wanted to do next was configure or change from Spring Security to using their configuration. So there's a security.xml in here somewhere. There it is. And you'll see here, it's got these patterns that it ignores. For HTTP authentication, it sets up these different roles, and it sets up an authentication manager, and then it has some global security down here that says, hey, for get users and remove user, only admins can do that. So we'll create a new class called security config. Boop. My border collie hates that. He screams from the other side of the room whenever there's that boop. Starts running. So this extends web security configure adapter. It's got this enable web security. It pulls in our user DAO because that's what we use to authenticate. And then it sets to ignore, some ANT matchers, and then for HTTP security, it sets up CSRF disabled because AppFuse doesn't have that yet. Headers and frame options, disable those as well. And if you ever see Spring Security, they do a good job of making this stuff look better, right? Setting it up like that. But when you reformat it with IntelliJ, it goes back. So it'd be cool if IntelliJ was smart enough to know that you want to set it up like this, because it looks better when you set up, form login and everything under it, and then you set up remember me and stuff. So IntelliJ is trying to tell me something here, right? It's, hey, your user DAO isn't what you think it is. And it's interesting because it does work with XML, but with Java it actually has a problem. And what it turns out it is we actually, the user DAO doesn't implement user details, which Spring Security needs. If you look at the user DAO at JPA, it does. Right, it's right there. So this was never a problem, and like a bug that I wasn't aware of. So in here, all we have to do is make that, and then our error goes away over here. And then this has, all those same configurations in it for permitting all, and has any authority in allowing certain users. And the form login has defaults where it uses username and password. Because AppFuse is kind of the old way of using Spring Security, it uses J underscore username, J underscore password, J security check. It has all those. So I just had to configure those because those weren't the default. And then basically, I thought, well, let's try to see if we can use those files instead of all these context files. right? So we have all these in here, and we kind of want to get rid of those. And then we want to use resources config. I guess it's not going to do the code completion for me. So we have resources config. And the reason this isn't working and why it thinks it's funny is because we need to set it up for annotation processing. So there's a context param, and it's called, what's it called again? It's like, I'm gonna have to go look here. I think it's annotation configuration. We'll go back to my commits. So we have that one, we have that one. And then this context class is what we need. So it's called context class. And you do annotation config web application context. So it's cool that IntelliJ is smart enough to say, hey, you had an error there, but now you don't because you know we parsed the file. So now you can do com config, and we have JPA. I don't know why it doesn't like the spelling of my name. You would think it knows who I am, but maybe not. Service config, and then we have security, right? And the rest of these, well, this one's empty, and we don't care about CXF right now. Okay. So now we might be good to go. Let's see if we can run it. nvn jetty run. So if it's going to blow up, it should blow up at the beginning, right? Because it's parsing those and it can't find certain files or it can't find certain beans that we have named because other classes depend on those. So it's initializing. Look at that. That's pretty cool. So now if we go back here, localhost 8080. We can actually log in. So we were able to convert those XML files, right, to JavaConfig. So that's pretty cool. What do we want to do next? Let's do that method level security, right, on our Spring files. So we'll shut this down. And it's called enable global method security. And then it has different options. Pre-post enabled. Those are pre-authorized and post-authorized annotations that you can put on your methods. Those are provided by Spring. You can use Spring's expression language in there. And then there's also JSR 250, which they renamed to secure enabled. True. So you can put those on there, and then it'll look for those annotations and set up things accordingly. So if we look at user manager, we can now say for get users, or get a single user. Now we'll just do it on this one. You can actually add, secured, and then you can do and then we'll fix our Java doc. Thank you, IntelliJ. And down here on remove user as well. So same thing we had in that XML file, we're just able to do it in Java now, a little cleaner. Any questions at this point? So the last three things we're going to do is remove the web XML. Right? That's kind of a nice one. We're going to migrate to Spring MVC config from using their Java config, and then we're going to migrate to Spring Boot. And if we have enough time, we'll go ahead and convert that Maven file to not XML. So to remove the web XML, if we look at that, we want to see what's in there. You can see here it's got a bunch of context parameters. It's got some filters for doing the display tag, some locale stuff, a rewrite filter, security filter, page filter for site mesh, a whole bunch of mappings, and a whole bunch of listeners. So we're going to put this in our web app directory because it's not really config, it's web config. So we're going to call it webconfig.java. Oh, wrong class name. So interestingly, here's how, this is what Spring provides. This is the Spring class here, from their web, and you create whatever you want to name it. You extend or implement web application initializer, you implement this on-startup method, and then you can say, it doesn't matter if it's a context parameter, you just set a init parameter on the servlet context, and this is what it looks like. So you're still, hard-coding strings in here, but you set that context class to this one, and of course you could use actual class and do get class on it, right? And it would get that name, so you don't have to use strings. Same thing with these init parameters, right? I just took straight what was in that XML and kind of put them in here. And to add filters, you use this filter registration, and you add it with what name you want to give it, and then what the class is. You can set init parameters on them. You can set mappings for that, similar with all those. And you can set whether does filtering on the dispatch or the forward or the include. And then we can even register our CXF servlet there. And then the listeners, you just point to the class. But you'll notice here we have a problem here with our menu context listener. And if we started it up, actually site mesh would fail as well, because you see there it doesn't find those either. So the difference is with XML, I'm able to have those dependencies as runtime dependencies. And they get pulled in when the app starts instead of at compile time. So to make things work, I have to go into the pom.xml, and I have to add a couple new dependencies. So now that I have those in there, this guy should resolve. I named it wrong, web app initializer. Sorry. So now it resolves and everything's there. So big moment of truth. Web.xml, point me to it. And now delete it. Now we'll go here and we'll go clean. So you can see there it detected that on the class path, initialized everything. If we go back here, we didn't check remember me, so it prompts us again to log in. And everything appears to be working again. Interesting, if you go here, you get a yikes. Remember these from the old tiles days and struts? And then you go to your console, and you're like, what happened? And you're like, what? Nothing? So the way to fix that, I didn't write it down in a live template, but out here you can see on this file, here's how I found out the old, what you're not supposed to do for security purposes is put a stack trace into your code, right? This is a no-no because then people see where your code is, but I turned up logging and everything and I couldn't figure out what was happening. So this is because it's kind of an old library that we're using that causes this. So if I go ahead and add this, if there's an exception, then go ahead and tell me what it is. It says you haven't configured that validator stuff, right? So if we went back, this was actually from the last part where we converted this validation file. We didn't load that up, we didn't convert it. It's got this default validator factory and default bean validator, and this was a module that Spring developed way back in 2007 for Commons Validator, so it could do client-side validation with JavaScript, and it says, hey, you have a required field here and stuff like that. So this is outdated, I need to change this anyway, so I didn't bother configuring that. But in order to make, those clients work, it does use JSP tags that reference this library to figure out if they should, make a field required or not. So what I recommend for validation nowadays is use HTML5, where it has that required tag that you can put on there. And maybe, if you have a JSP tag or whatever, then, it can do that for you. But I typically think that UIs are better written in JavaScript than they are in server-side templating. So that's why HTML5 comes in. And until you have a way of talking to your REST API and getting your validation rules, it's difficult to actually have a form on a JavaScript client that knows the rules from your server. So now the last thing is this dispatcher servlet. We're still talking to that from this web application initializer. You'll see here we have that dispatcher servlet loads up that XML web application context. Let's go ahead and migrate that. You can see in here it's got exception resolvers, some message sources, some scanning, but it's got a view resolver. It uses annotations for all the controllers, but it still has that file in there, so let's get rid of that one. Call it web.config. So this one has the enable web MVC on there. So it configures MVC, and then it's got something it doesn't like. Not sure what. You see any red lines anywhere? Down here. Doesn't like that I don't have a closing thing. Come on. I gotta copy it. Copy, paste. There we go. So it's pretty much everything that's in that XML file, right? But now it's in Java code, so they're all beans. It's got the registry here. We can add another one if we want for the home page where we set it to be index. And then we can go back to our web app initializer and say, well, we don't want to do that anymore, right? And you're fine. I think that's what it is. Let me double check here. Right, you just remove it, set it to new dispatcher servlet. Yep, that web config, and that's it. You can see those validator beans I have commented out here. So we'll just make sure Spring MVC still works. I'm sure it does. Let's go back to doing Spring Boot, because that was one of those things at 3 in the morning that I was like, I don't know if I should really try this. I mean, I know it's a good punchline if we get it to run under Spring Boot, but I don't know if I should. So I was like, what the heck, let's try it. So let's see if we can make it work today. I mean, it's been a pretty successful demo so far, I think, because, I mean, we're still proceeding and we haven't given up and gone to that GitHub repository. So we have this application class. And with Spring Boot, it's as easy as just setting up, this enable auto configuration as an annotation, your application, and then a main method. But you have to actually add the dependencies. All right, so we'll go in here and we'll say, okay, not that one. Spring Boot, starter web. And then let's take it even further and let's get rid of that JPA stuff and let Spring Boot manage our data source for us, since it does that quite well. Data JPA, and then we'll go ahead and add our own in-memory database. So we can do that just by specifying H2. So if we go back here, now everything's resolved. We can get rid of the long imports so you can see it a little better. So it's this class. We happen to put it in web app. I do want to move it up just because I think it should be at the root. And now we can delete JPA config, because we're not going to need that anymore. And in resources config, these Hibernate properties and JDBC properties we're not going to need. So that's trimming it down, and we can get rid of this guy. All right, we don't need that anymore because Spring Boot does this all for us. The one thing that we do have to do, well, I'll let you see the error first. So with base DAO test case, obviously you have to take this out, but then what you do is you set it to be Spring application configuration, and you point it at that file we created. And then you can also do web app configuration. And I agree, you shouldn't need this on your DAO test, but again, it was 3. I got it working, so I'm going to show you how I got it working. I'll figure out how to do it better and probably blog about it later. So let's see if we can run that user DAO test. Oh, we still got JPA config referenced here. It's got a lot more logging, that's for sure. So if we look here, basically trying to tell me that it can't find the persistence unit manager. So I can't show it to you, but maybe if we did back here and tried it. MVN test, dtest equals user. It'll be a little easier to read. So there it is. It says basically, hey, no qualifying B of type energy manager factory is found. This is one of those things I was like, what? I can't even understand this. So then I go back here. I don't know how I managed this at the wee hours of the morning, but it was on generic DAO JP8. This persistence name is default by conventions in Spring Boot. So I had it named something else. I ran it, it's still complaining about something else now. Energy Manager Factory. Well, we're getting close to the end, so I did get it working, and I was pretty pumped about that. So I'll just show you what I did in here. So we added those, starter, palms, and then we created this application thing. I did have to add that exception processor. I deleted the JPA config. I took it down to mail.properties. I made some adjustments there, changed that to default, and then this could be the key right here. I had to specify those in an application.properties. And then the base DO test case, like I said, I had to add that, change that unit name to default. Oh, it's in the user DAO test, that's what it was. And then application.properties, which Spring Boot uses. You can also do a YAML file. Let's see if adding that exception translator helps. And if not, I did get it to run that morning, so I was pretty pumped about that. Now, if I can't get it to run here, I'm okay with that. So I know I did get it to work, so I'm happy with that. So the last thing is how do you, get rid of this POM file that we have that's all this XML, right? Do we migrate to Gradle? Well, you can, because Gradle has this handy feature where you can do Gradle init. And it says it's incubating, but basically you get a build.gradle. And it's got all those dependencies in there, so that's cool. Let's try it. Gradle compile Java. Cannot find method provided compile. Wow, that's cryptic. Then you go here and you're like, okay, I Googled, I figured that out, that I needed to apply plugin war. And you go back. And I did learn last week that you don't have to do proper case on your tasks for Gradle. You can do whatever you want. So it looks like, it's got some diamond operator support. So the conversion isn't, very good because it doesn't recognize them using Java 7. But it actually compiled everything, so that's how you can convert. But the one thing it doesn't do is it doesn't have those plugins. What I found is I tried to make all of AppFuse using that Gradle init, convert it from Maven to Gradle, and what it does is it just puts your dependencies in there. So it doesn't actually convert your plugins from Maven, and the Maven plugins probably won't work with Gradle. So if you really hate XML, there is another option, Polyglot Maven. If you go here, they show you how to do it. Ironically, you have to create an XML file to use it. So I'm not really eliminating XML, but if I do make dir mvn, and then vi mvn, I think it's called extensions. You have to be using Maven 3.3. Then you can put this in here, and we'll do Polyglot Groovy. And then you can basically, it has this command you can run to convert your file. You can say, okay, I want to do Groovy. And then if you look at that, it's not XML, but it's pretty much the same thing you had before, right? It's just different syntax. But you can remove the pom.xml, and you can do Maven clean compile. And it actually works, so it's kind of neat. So to recap, we did change from Java Spring to Java XML. We changed from Spring Security XML to Java. We replaced the web XML. We converted Spring MVC to use Java for everything, and we migrated to Spring Boot, and our tests are failing. But they did pass at that 3:30 in the morning, and I was so pumped about that, you wouldn't believe it. So you can do that like I did, or you can just use JHipster because they do a lot of that for you already. And one of the questions is, how can things get even better? I'm not sure. I think Spring Boot does a pretty good job with its conditional stuff. I think a lot of it has to do with better defaults, right? In the sense of expecting a certain, if you put the JDBC driver in the class path that knows you're going to use that database, don't make developers configure things, right? Like default, let them override it. Convention over configuration, and I invite you to go forth and remove your XML. It was never that great anyway. Any questions? So like I said, this project is out there on GitHub, and I'll post this presentation, and feel free to stay hip and follow me. And I have some business cards if anyone wants one, but thanks for coming.